of the challenges we have with the website and some of the opportunities that might be available. So I'm just I'll introduce Irfan, who on my screen setup is different than everybody else's, but Irfan is coming to us from Calgary, and he's helping out in the coordinating. And then Muxiar, who's down there on my screen, is coming to us from Quetta. And he's helped organize the Zoom meetings together with Irfan. So they are our hosts from Pakistan. Many of you know Gary Johnson. Gary is emeritus up at Dartmouth College in the Earth Science Department. And Gary, of course, was my thesis advisor in Pakistan. So I'm delighted and honored to have Gary with us. We've got Kay Berensmeyer. Many of you know Kay has worked in Pakistan for many years, and Kay and I actually worked together in East Africa a long time ago, as did Kay and Gary. So there's a lot of connections here that span East Africa and Pakistan. Larry Flynn is here with us, a representative from, whose background I don't know deeply, but I'll say a representative of the Yale team.
Now Harvard.
Now Harvard. April is next on my screen. April has been helping me for many years putting together the website that we'll talk about at some length here in a few minutes. So April is a web guru, and she lives in Erie, which is near, or excuse me, in Lafayette, which is near Longmont. We've got Kathy Sarwar, who is Sarwar's wife, and Kathy is coming to us from Louisiana, and we lived together in Houston for many years, and we worked for oil companies, her husband and myself, and we've had many collaborations over the years, which I'll mention. I see Catherine Badger, part of the Harvard Yale group.
Yeah, I'm at the University of Michigan.
At the University, okay, at the University of Michigan. And then I see Amjad Qureshi. I'm not sure, Amjad, where you're from, but we send our greetings to you.
Yeah, Amjad is from
Hi Gary,
Iran.
this is hi Gary, this is Amjad here. I'm Irfan, how are you?
Good. Yeah. Thank you.
I'm Amjad Qureshi. I'm from Pakistan. I work for Mari Petroleum, based in Islamabad these days, but I'm a graduate from Department of Geology, University of Peshawar, then National Center of Excellence in Geology, University of Peshawar. Over.
Good. Well, good. Mubarak, it's good to have you with us. Thank you for coming. And we've got Mahmoud Raza is here with the Yale Harvard team. I don't see your picture, but I see
there he is.
Hi. I'm heading for work, so that's why I just unmuted my video and the microphone.
Well, it's very kind of you to join us even as you're heading for work. We'll work our way through this. Yeah. Let's see. Then we've got Atiq Ahmed, and I'm not sure where you're from.
That's our graduate, currently working in a mineral industry. Last night he missed that, so he asked me to send him the link.
Okay, that's good. Good, wonderful to have him. And then Azaz is the Galaxy S9.
Yeah, he's also a graduate, and he's working in the oil industry and Mari Petroleum, which is actually based in Islamabad.
Oh, very good. It's good to have representatives from the oil industry.
Oil industry, yeah.
Yeah, it's nice. We'll talk about that a little bit. And then I see Doug Burbank has just come in. His video hasn't linked up yet, but many of you know Doug. He's in and out of this meeting here, but Doug is based in California. There you go. I see Doug. And Doug, we're just sort of looping some introductions, but you'll see some familiar faces here.
Yep.
And
hi, Gary.
How you doing?
Good.
Good.
It's really good to have all you guys together. And what I'm going to do is I'm sort of reviewing. We had a gathering last night that I was intending to have everybody at, but I had a minor miscalculation about how the Earth orbits around its axis, and I think I had it orbiting in the incorrect direction or something. So I reversed the polarity, and in any case, I screwed up. And so we've got this meeting this evening. There'll be a few people from Pakistan that couldn't join us last night. And but for those of us who are here, what I'll do is I'll just quickly spin through some slides just because we showed them last night, so you'll see what I showed. And I'm going to need to get screen sharing permission here, Mukhtar, in a minute when it's easy. And then we're going to review the website, which is called siwalikstratigraphy.org. And some of you have seen it before. And it's the website that April and I have been building for a considerable amount of time. And the intention of the evening, as I tried to express it last night also, is really to introduce the website, but also to get feedback on how it can be made better or more useful. Because what it's really intended to be is it's a collage of the labor of many people, many organizations over many years. And what I'm trying to do is assemble it into a format that can be readily accessed by anybody around the world. And I was in Pakistan a couple of years ago with Ghulam Sarwar, who I'll show you a picture of him in a second. And it was clear to me that even though everybody's working super hard, it's pretty easy to forget where there's measured sections or where there's known magnetic stratigraphic data. And it's partly because some of the data sets are published in master's theses or not readily available. And it's also because it can be a little bit tricky when you're on the ground, knowing where the heck the people worked in the past. And so we're trying to build a tool using the technology that's now available to allow people on the ground to figure out where people have been in the past so they can take advantage of the labor. So that's really the bottom line, is to capture that effort and to get it accessible to people who are in the user community. So I'm still disabled for my screen sharing, Mukhtar.
Okay. I'm just.
Yeah, you have to transfer the host authority.
Yeah, this is a Dickens of, we all learn this bit by bit, but and I'm not very good at it myself. So you're going to see a bunch of flailing here.
Okay. Now you are the host.
Yeah, I'm very close. I'm close to doing what I want to do. You guys have to tell me if you can see my PowerPoint.
Yes.
Yes.
Now we can.
So hang on a minute. I'm trying to start in the right place.
JPK.
Yeah. So now I'm assuming you can see my PowerPoint, and I'm going to go through this relatively quickly. Some of you are very familiar with a lot of the material, but I just want to grind through, sort of show you sort of the framework of the Siwaliks as I see them, and everybody's got their own way of working at it and their perspectives. But I want to start out with a reminder of Ghulam Sarwar, who was, he's a long friend of mine and alas, no longer with us. But Ghulam and I went on a trip to Pakistan a couple of years ago, and we gave talks in Islamabad at the GSP and at the Academy of Sciences, and we gave talks in Peshawar at the Geology Department and also at the Center for Excellence, and we gave talks in Quetta at the GSP, and then we went down to Jamshoro, which is near Karachi, and gave talks there as well. So it was a wonderful opportunity to travel through Pakistan and see many things with Ghulam as my host. And he was a wonderful friend and part of the inspiration for this work. And this is Teresa Hill. She's did a lot of the drafting, particularly the redrafting of many of the sections or the coloring of the sections. And she, alas, is no longer with us either, but her smiling face is with us, and she was extraordinarily helpful in helping me put together the website together with April. So April and Teresa and I have put this together as a collaboration. Let me go front, whoops, sorry. So that just to emphasize that there's many organizations, of course, that have been critical and instrumental in assembling these projects, and a lot of it was funded by the National Science Foundation. But Peshawar University and Dartmouth College, under Gary's guidance with Dr. Tarhelli, and then the GSP working with Yale University and later Harvard with Dave Pilbeam and Mahmoud Raza and others, really were the sort of the primary elements. But the Fulbright program got involved. My wife, Mary, and I did a Fulbright in Peshawar. Several others followed us. And then a variety of other universities, of course, have been involved. Neil Updike at Columbia, and now Harvard working with the Yale group. Oregon State, Bob Lilly and others, University of Arizona would be Ev Lindsay and others, University of Southern California would be Doug Burbank and others. So many people worked on this project over the years. And it's been a great joy. Let me just make this go. Here's Rashid Karcheli and Gary. This is up near New Mirpur in what's called Jelkas, and it's a measured section, goes right through here. You can see the kind of the thick sandstones we had to go through. But Rashid was a magnificent host. There's so many of us, and we're profoundly grateful to the collaboration between the University of Peshawar and the team to put this all together. There's another picture of Rashid with the Dartmouth Land Rover that came from East Africa. As you can see, that's the East African Land Rover up in the Karakoram Highway somewhere there.
APK.
Yeah, KPK.
It was.
So here's this is the Yale team, and you guys know yourselves as pilgrims behind the camera there on the right, and this is in the core area.
No, this is Y311. It's near Sethi Nagri.
Oh, near Nagri. Okay, I'll fix my caption. Okay, I'm going to keep on going.
This was the time when I joined geology and you guys were doing field works, and I could see you going to the field with Rashid Ahmed Khan, Tahir Khaili.
Well, that's good. So, you know, we set the stage last night with the tectonic setting, the beautiful National Geographic diagram, and then a DEM showing the regional setting of Pakistan and Afghanistan, parts of India, and just sort of to lay the groundwork. And then I've got this diagram that we eventually should redraft, but it's sucked off the internet somewhere. But, you know, it's really important to stress that the rivers define the landscapes of Pakistan today as they have in the past. And when I was over there a couple of years ago, they were having drought conditions, and there was issues about the water supply for Karachi. And it's particularly interesting, of course, the Indus is the river that comes down to Karachi, and the water supply is used largely for irrigation in Pakistan, as in many other countries around the world. And so there's a dynamic challenge between the people that are trying to irrigate the Punjab and the people down in Karachi that are trying to drink the water. And so the rivers are relevant as they have been through time. And just a fun comment there. And then this, again, a crummy sketch that I've used for many years, but this serves to point that the Indus system and the Brahmaputra system and some of the tributaries to the Ganges all originate in a similar spot up in the Himalayas, north of the Himalayas, actually in the Suture zone, up near the mountain, Mount Kailas, that Ganser wrote about so nicely. And so that's, if I can, I don't know if you guys can see my pointer, but Kailas is right about in here.
Mhm.
Can you guys see the pointer?
Yes.
Yeah, okay, good. So Kailas is sort of about here, and it's relevant because I'm going to take you there in a second. This is a map that shows that the molasse sediments are thick to the north. The red is the thicker accumulation of Siwaliks, and they thin towards the south. And so that's the general thickness pattern. But here we're on a little trip to Mount Kailas, the headwaters of the Indus River, basically. And there's two lakes up there, Lake Raksas Tal and Lake Manasarawar. And here we're walking around the edge of Lake Raksas Tal, heading towards the Trans-Himalayan range, which is in the clouds up ahead across the Suture. And fantastic territory up there. You've got to go right by these yaks. They're reasonably accommodating. And then you get to the point where you can see the mountain. And actually the mountain can be seen from a long distance away, but this is a beautiful spire of conglomerate shed off of the Trans-Himalayan range. We're actually walking across the Barga plain here, which is the Suture. The Suture runs right east-west across the screen here, and we're walking perpendicular to it, heading towards Mount Kailas. And a colleague of mine, Ned Stern, who did his master's at Dartmouth, and we did a loop around Kailas. It was a wonderful experience. And then, of course, you follow the river downstream, and you end up coming down to Peshawar. And this was a picture taken in Peshawar back in about 1978 or 79. And the inner city of Peshawar hasn't changed that much, but the periphery is changing dramatically. They've been building flyover superstructures for the incoming GT road, which is now double pathway and super fancy road. So there's a lot that's changing, and there's a lot that hasn't changed that much. So the chicken soup wall is probably still there somewhere if you poked around, and you can still find the dentist when you need it. And just Mary going to the dentist. And then the guys making the rugs are still there. And here's Mary bringing a rug home. And we sat out on our backyard. And this was the year that we were teaching there in Peshawar. And we'd had our tea outside in the backyard. Wonderful, wonderful experience. And the Fulbright program was a fantastic program. And I'm not quite sure if it's still operating in Pakistan, but actually my son did a Fulbright in Jordan here like a few years ago. So it remains a fabulous program, and I'm obviously an ardent supporter of it. Then a couple of years ago, we came back into the subcontinent, and after a trip to India, that's when I went back over to Pakistan and met with the Ghulam Sarwar. Here we are now, we're looking at the rivers and the river deposits. Again, just a quick speed through this. This is the Indus River actually near Attock, near the confluence of the Kabul River. And you can see there's cobbles in the Indus. The class size is pretty significant. And of course, this is a proximal facies today. And the modern river systems are keys to understanding the past. The geology of the Siwaliks is written, it's the writing of these rivers through time. You can read the history of the rivers by looking at the Siwalik sediments. And you come down onto the plains, people are wonderfully hospitable. Those of you who've done field work in the Patwar area, you'll know that you're constantly being invited in for tea. The people are wonderfully eager to have you. And it's a great joy to do field work in this area, wonderfully helpful people. The sedimentary rocks are very well exposed in Pakistan, particularly in the Patwar. John Sticks here looking at some trough cross-bedded sandstones. And these sandstones indicate the direction of currents. Here's Noy Johnson with, again, John and my wife, Mary. And Noy, who is alas no longer with us, but he's pointing in the direction of the flow indicated by these cross-bedded patterns in the sandstones. This is down near Chinji and Kamlial in the southern part of the Patwar up against the Salt Range. And we've studied the Paleo Currents, and if you have good exposures, they're pretty easy to measure. And of course, the river systems are generally flowing to the south, but there's strong indications that many of the old Indus River system flowed to the east, southeast, or even easterly. And it may well be that the Indus used to flow into what's today the Ganges system. And it could be suggested that it had been pirated as recently as maybe 5 or 6 million years ago to flow into its current orientation down towards Karachi. Wonderful exposures, the red beds. These are some of the paleosols and red beds developed in the Chinji facies. And lots of variation in terms of sandstone architecture. Multi-storied sandstones are common, particularly as you go to the north. And here you can see a stacked series of channel sandstones, one on top of another. These are all fluvial systems. The rocks were laid down by ancient rivers, with the intervening mudstones or siltstones being associated with the floodplains adjacent to the rivers. The way we studied the rocks for the magnetic stratigraphic studies is we would take oriented samples, and here's Gary taking a sample from a siltstone underneath one of the channel beds, and he's being very careful to scribe the current direction on the physical sample itself, and then the samples are taken back to a laboratory. We would cut them into cubes. There's a variety of different techniques for doing this, but we would cut them into cubes. The cubes would go into a magnetometer. Here you can see it on the upper right. And the magnetometer, after a variety of demagnetization techniques, would print out results that were indicating the ambient magnetic field at the time the sedimentary rock was deposited. And that's a very important point, and something that Neil Updike and some of his colleagues back probably in the tail end of the 60s figured out that the magnetic polarity signature is recorded in the sedimentary rocks. And you can build stacks like this. Here's an example with measured section in meters and the magnetic polarity indicated as this alternation between black meaning normal and white meaning reversed. And those polarity patterns can be recognized and tied to these patterns, which were seen on the seafloor. And as most of you will remember and know, really the key to seafloor spreading was the interpretation that these magnetic anomalies that were observed on the seafloor represented the spreading of the seafloor across from the mid-ocean ridge. And here, this pattern is just south of Iceland. You can actually walk in Iceland. If you come up near Reykjavik, you can stand on the chasm, one side of which is the eastern side, one side is the western side, and you can see Iceland being split asunder by the mid-Atlantic ridge. And you come down offshore and you see the same magnetic pattern preserved on the seafloor that we see in the sedimentary rocks in the Siwaliks. The other thing that's very important for us in terms of dating the rocks is the occurrence of volcanic ashes. And here you can see this is near a place called Bangala on the sort of northwest of Dina. And you can see the white stripe there on the ground is a volcanic ash. Here's another picture of an ash behind the rock hammer. And these volcanic ashes are airfall ashes, and they contain tiny zircon crystals. And the zircon crystals can be dated using fission track dating. And Gary Johnson and his colleagues did a series of zircon dates using fission track that allowed us to calibrate the record. And you go from having just a black and white polarity system. Here are two volcanic ashes that were dated. I'm looking at about the 420 and 470 meter zone here. Those X's mark the ashes. They were dated and they indicated that this polarity boundary is in fact the boundary between the Gauss and the Madhyama. That's right here. The other thing that's important is these bone symbols represent fossils that have been found. And working with Ev Lindsay and others, one was able to roughly date the sedimentary rocks based on the fossils. You could get precise dates on the volcanic ashes, the airfall ashes, and they would allow you collectively to pattern match the magnetic stratigraphy tied to the worldwide dated polarity change history, and that allows us to date the rocks. So the Siwaliks represent some of the best dated sedimentary rocks in the world because of the abundance of measured sections and the abundance of the paleomagnetic studies. And it's one of the great records of sedimentation available in the world is present today in the Potwar Plateau. Fluvial Faces, a diagram that Gary put together and published in 1979 in the Case de Jong volume, just indicating the variation between multi-storied sand-rich to less sandy, muddy facies. And of course, these facies are reflective of the Paleo landscapes. So the landscapes, if you're close to a mountain front, you'll get these big coarse conglomerate faces that you see here in a photograph that Gary loaned me. And then you'll watch, if you watch these things through time, you'll see the coarse facies. If you measure them in a variety of places from the north to south section, you can see an actual migration of that facies pattern through time and through space. Of course, this was a troubling thing for the early geologists because a lot of the early mapping was done based on facies, and the facies turn out to be relatively diachronous or capable of changing their occurrence in time. And so it was difficult for early workers because of facies that was called, for example, Dokpatan, might be one age in one place and another age in another place. And there was a lot of confusion in the early days, particularly as they tried to work out the paleontological history and record. So the magnetic stratigraphy provided an alternative mechanism for dating the rocks with extreme precision. And it's given us this fantastic story about the evolution of the landscapes. You can also look at changes in rates of sediment accumulation through time. This is important for the hydrocarbon story. And we've got a couple of representatives from the hydrocarbon industry here. And I had to stress we talked about it a little bit last night, that there's not oil and gas so much in the Siwaliks because of the lack of source rock, but the Siwalik sediments provided the load that buried the underlying sediments and allowed them to get into the pressure and temperature window to permit the maturation of the hydrocarbons beneath the Siwaliks. And in some cases, some of the oil and gas might have migrated up into the Siwalik sediments. And so there are oil and gas interests in the Patwar. There have been a variety of oil wells drilled with some modest success at Hadi and other places. And of course, there's also oil wells or tests that were drilled in India. So there is a record that'll come from industry that can help support the record that we have from surface exposures. And you can see there's variations in sediment accumulation rates across, again, time and space. And there's some possibility that there's low accumulation rates followed by higher accumulation rates followed by lower accumulation rates that might represent migrations of depot centers. And this can be put into spatial view with diagrams like this. And here you can see we're looking at accumulation rates in terms of centimeters per 1,000 years. And the size of the circle represents the rate of sediment accumulation. And you can see that there's high rates of sediment accumulation up in this is the Jhelum reentrant. This is the Mangla Reservoir area near the town of Jhelum, which would be down here. And then you can see lower rates off on the periphery. So the rate of sedimentation is tied to the spatial position of the spot that you're looking at. Some of these facies rates move pretty quickly. Here's the conglomerate advance from north to south, and you can see it's changing at about 3 centimeters per year, which we enjoy the fact that that's about the same as the rate at which the Indian plate is moving, which might be a little bit closer to 5 centimeters per year, but the facies change rates and the plate motions are of the same order of magnitude. And then Doug and I put together a series of diagrams synthesizing some of his thesis work and my thesis work. And here's a series of paleo landscapes. And I've been working a lot at the Denver Museum building paleo landscapes. And we have artists now we hire and they do landscape paintings. And here Doug and I had to be a little bit artful about hiding the part that we didn't really know that much about. So you'll see that you can see the front of the picture, but the middle and the back of the picture is sort of left to the viewer's imagination as to what's going on back there. And we might be able to work on that and get some more detail. We also built a little block diagram like this where you can see the front face is sort of a northeasterly, and the other face over here, the left face is sort of northwesterly, or northwesterly. And important thing here is that some of the faults are extremely young. Of course, still moving today, you feel the earthquakes, but something like the Pir Panjal range, which is a big mountain range northeast of Mangla Reservoir, that actually bounds the Kashmir Basin, appears to have been developed largely in the last 4 to 5 million years. And the ponding of the sediments in the piggyback basin was the subject of Doug's PhD dissertation. So I won't say many more words about it. If anybody has questions, we've got Doug right with us. But suffice it to say that if you'd been looking at this landscape 6 or 7 million years ago, it may well have been very different because the Pir Panjal range may have been much less developed. And so the overall topographic expression of the Patwar region has changed significantly since the back and tail end of the Miocene. And the same thing's true over on the other side with the Peshawar Basin up here. It's probable that some of the faults that bound the Peshawar Basin in the Attock area are also very young. And so the whole configuration of the landscape that we see today in the Patwar Plateau and in the Indus River area is a relatively young development. So the paleogeomorphology has really changed dramatically in not that many million years. And a last couple of diagrams just to show, here's a plan view map of the Chenab River over in India, but illustrating the sort of a hypothetical distribution of rock facies. You've got erosion up in the mountains, you've got the conglomerates up near the mountain front, and then you've got very thick sandstones in these structurally controlled reentrants with thin sandstones on their margins. And this is a plan view map. And then if we look at it in a cross-sectional view, this is the Jhelum reentrant. calibrated by a series of magnetic polarity stratigraphic sections. And you can see a conglomeratic facies up in the youngest part of it. And then you can see as you move down, you've got the massive sandstones in an axial position with the thinner sandstone facies developed off on the sides. And again, this just illustrates the influence of structure on the style of sediment accumulation, or the facies of sediments that are accumulated. Again, something that we can document pretty nicely using the magnetic stratigraphy. We're going to now, I'm going to make a transition over to the website, but I'm going to hit a couple of images. One of the things that I've done in COVID time is I borrowed my wife's computer here at the house in Longmont, and I redrafted my thesis map, which had been made from a myriad of air photographs and had all kinds of, you know, incremental distortions in it, one thing and another. But this map will float directly onto Google Earth. It's you can make this into a KMZ and float it onto Google Earth, and it'll fit precisely. It's made from Google Earth, and so it'll match precisely. And we'll visit this map again in a few minutes when we look at the website. Doug, I just wanted to highlight this diagram that you guys put together a few years ago, just showing how many of these stratigraphic columns there are. And it indicates, I mean, even for myself to try to remember which one is which drives me crazy. And they've all got wonderful names. If you measure it yourself, you know it pretty well, but if somebody else measured it, you might forget where it is. And so the website was a tool to help put these things together. And it's coming up in a second. Just to show another thing we're working on, I've redone the magnetic mapping on the Pobby Hills. And once you've got a magnetic map like that, as Gary and his students realized early on, you can make time maps. So there's a magnetic map. Here's the town of Jhelum. This is the Jhelum River. And there's a magnetic map, and here's a time map. So if you're interested in collecting fossils, you can go to the time zone of interest. And we've done the same thing down here at Kotal Kund. This is Yogi Tilla, the big ridge southwest of Jhelum. And Kotal Kund is the little town in here. And Gary and his colleagues, Carol Frost and others, did a lot of work in this area. And we can make a time map of this area as well. And here's, the colors are a little bit gaudy here still, but here's the time zones are indicated in millions of years, and they're laid down and calibrated based on a series of paleomagnetic stratigraphic columns. And now what I'm going to do, I'm going to get out of the PowerPoint, and if I can keep my wits together, I'm going to go to the website, and bear with me just a minute. It'll take a minute. If anybody has any questions, I'm just monkeying with my screen here, which is, I've got to find the right real estate. I think if you really do this, you have many screens, or you have a bigger computer. I'm doing this on a little MacBook Air. It's it's tricky to get everything to happen, but.
Well, I have a question here. It's regarding Chinji and Nagri.
Yes.
How do you differentiate between Chinji and Nagri?
Yeah, that's a wonderful question. So philosophically, you differentiate them on the basis of their facies, and the Chinji tends to be muddy and very reddish. The Nagri tends to be made of very thick sandstones, and it's a huge problem because many geologists, especially field geologists, want to define the rock that they're working on, and so we've had lots of discussions in the field as to whether something is it Nagri, is it Kamlial, is it Chinji, and if you're standing at the type locality, then you can be very sure that you're looking at the rocks that were defined to be, let's say Dokpatan, or let's say Nagri or Kamlial. But if you're moved away from the type locality, the problem is that the facies change laterally, and meaning they change as you move across the landscape. So what is Chinji in one place might not be, I mean, the same time interval might not be Chinji someplace else. So those words are, you have to be very careful with how you use those member names in the Siwaliks. And in fact, once you have the time control, the paleomagnetic gives you the time control, then you tend to not use those words as much because they can be very confusing. So we can discuss that in more detail, but I'm going to show you this website. This I just typed in siwalikstratigraphy.org, and it's got a header here. April has built this whole thing. There's a location map that'll just show you the same image. We're expanding this actually to go into India. And then there's two different columns over here. There's geo maps and sections, and you can approach things on the basis of mapping. And here we've touched the geo maps, and this is the front end of it. And these are regional or sub-regional maps that if you click on this little tag here, it will blow up that area. So for example, the Peshawar Basin, if I click on that, here's a map of the Peshawar Basin, and then it's got a couple of measured sections, but we'll talk about those in a couple of minutes. I just want to sort of review the map story here. And if I come back up to this, the index map, you can go over to the Kashmir Basin, do the same thing, and you'll see there's 4 little boxes there that relate to 4 different sections. There's a regional map for the Patwar Plateau area, and you can see there's a map of Kor here. This would be Kor. There's the Eastern Patwar. There's the Salt Range map, which would be G's maps of the Salt Range, and then some detailed maps. And if you go over the Eastern Patwar map, which is the one we looked at a minute ago on the slides, it's going to come up here in a minute. It's populated by all these little squares, each one of which has a handle on it, and you can click on those things, and it'll take you to a detailed map of that area. So the overall map is indicated here, but if you want to see a detailed map, you can click on the panel, and the way that it's constructed, those maps are just right here below it. So if you touch the Swan syncline, for example, if I hit this thing here, it takes me right down to that map, which is just hiding right below the pile of map or the index map. And you can see this is a great big stack of maps, and you can see Teresa has colored many of them, and we've tweaked them a little bit to make them as presentable as possible. But basically, these are the maps that are coming pretty much directly from the various publications. So they're coming out of published data, they're coming out of master's thesis work, some PhD thesis work, and a variety of student projects, including some undergraduate work done by Dartmouth students. So quite a big pile of maps, each with their sections on them. And the way this is set up, if you click on the purple, it'll take you to the measured section. So this is the Rotas area. Just the Rotas Fort would be just up here. If you click on this, it will take you to the Rotas section right there as published. And the reference is up here on the top, and these are all downloadable. You can come over here, you can download it, and then use it as you may. Let me just introduce this tab over here where it says sections. We're looking at the Pakistan and Kashmir window, and each of the orange dots represents a measured section. So each of these, and they're clickable as well, and they're stacked right below it. And you'll see, for example, if I come over here to Javed's Bain Pass section and click on it, it takes me right down to the Bain Pass section, and so on and so forth. And they're on the order of 50 plus sections here in Pakistan and in Kashmir. And then we've also got, standby, we've also got, if I come over here, we've got Western India, and here we've got 7 sections that have been measured in India, including Gary's section at Hari Talyangar, somewhere here, right there. And if you click on those, it takes you to the section. So this is sort of a way of archiving information. I mean, it's pretty much a library kind of a tool. You can do lots of other things. For example, we build a fauna diagram. Here's the fauna from the 5 million years, the younger fauna and the Siwaliks. And I put this together reading the literature pretty carefully. And there's a point here at about 2.7 million years where the elephant changes, the horse changes, and the cervids come in. So there's some kind of a, we talked about it sort of generally, but there's some kind of an avenue that opens, a gateway that opens right around 2.7. And it might be a ecological gateway, it might be climate gateway, it might be, someone lowered a gangplank across a crocodile infested moat. But these animals evidently came in here at about 2.7. And that's the kind of a thing that could be refined. And of course, there's additional data that John Barry and many others are working on in the older Siwaliks. Another thing that's on the website, and I'm getting close to the end here of my talking about it, but we put this reference stack here. If you click on the references, this gives you a bibliography of PDFs, and there's about, I think there's about 80 of them in here now, and 87 of them to be precise. And we're putting more in. April and I work on this once a week, so every week this gets tweaked a little bit. And each one of these things can be downloaded. So what I've done here is I've, with the good graces of my friends and colleagues, many of you on the screen, we've been able to put together a PDF stack, and these are available to anybody at a single click. So the philosophy of the website is really designed to make available to people in Pakistan or anywhere else the information that has been assembled over the so many years by so many people. And what I'm really interested in doing now, I'll maybe stop sharing my screen so we can see each other. What I'm interested in is getting feedback from the user community. We had a considerable discussion last night. People were interested in provenance questions. They were interested in mineralogy questions. They wanted to know about uranium deposits. They wanted to know about oil and gas potential. We talked a little bit about groundwater possibilities, and so really the question for the group would be, what other kinds of features might you like to see on a website like this? I've talked about putting in some of the cross sections that people have put together. We talked last night about maybe getting a seismic line. If they can get one or two released, we could put a seismic line on there. We've talked about maybe putting some of the block diagrams on there, or some of the panel diagrams. For example, the panel diagram from core, it'd be nice to color it up a little bit and put it on there. So I'm going to now turn it over to a group discussion, and I'm keenly interested to hear people's thoughts and feedback. And we're a small enough group that if somebody's got a question, you can probably just holler, but if you wave your arm, we can address you individually, but you'll have to unmute yourself.
It's absolutely great. I love that.
Well, I'm interested in, at some level I did it to help myself see where the stuff was. But when I was over in Peshawar in particular, I was in Peshawar University at the geology department, and there are people that are keenly interested in the Siwaliks. And many of the theses are in the Center for Excellence library, and they're available, but you sort of have to know they exist. If you don't know they exist, it's going to be super hard to find them. So this website is really intended to, in a sense, to lay it all out there. And so Larry, that's why I'm doing it. So I hope people find it useful.
You've done
Hi,
a
Bob. This is Amjad. I've got a question. When I was doing my MPhil thesis, I was measuring a section near Shakardar area, not exactly Siwaliks, but Murray Formation. And with me were Dr. Iftikhar Abbasi and Dr. Saifullah Tanoulis from National Center of Excellence in Geology and Geology Department, University of Peshawar. And we measured a section where Murray is 125 meters thick. When I joined Murray Petroleum, we drilled 3 wells there in the same area. And while drilling the well, the Murray was more than 1,000-meter thick. So what could be the reason that at the surface, the complete section, bottom is exposed, top is exposed, section is 125-meter thick, and in the subsurface, when you drill the well, same formation, you get more than 1,000-meter thick. Oh.
And I must add that Murray actually poses a lot of problem when you are drilling in the cohort. So that's probably one of the concerns, if I'm wrong.
So yeah, the other thing that one of the challenges with the Murray is that because it tends to be in the northern part of the region, it tends to be structurally involved, and I'll just say it's faulted, and you might have stacks of faults. Some of these thrust faults can be very planar, and you can get stacks. It's possible to get an imbricate stack, and I don't know the situation where you were drilling, Amjad, but it's perfectly possible that you were measuring the correct thickness of the surface, but in the subsurface, you might have been drilling into a package that actually was accumulated in a very different setting, and it also might have had structural thickening because of stacked thrust faults. So it'd be interesting to have a seismic line across that area where you could maybe tie from the surface into the subsurface. That might be an interesting way to help solve the problem. And as far as I'm concerned, the Murrays are just the older continuation of the Kamlial. So, we make a difference because they look so different, but philosophically, the Murrays are the antecedents to the Siwaliks.
Possible
Well,
that the
I did.
it's possible that the archive from PPL or the Amoco concession that existed for about 20 years in the 70s and 80s is on file somewhere, because I know Amoco in their concession areas south of Kohat had quite a few number of seismic lines that were put in, and I can't imagine that's been thrown away. It must be on file somewhere in the survey office, or maybe it's been acquired by one of the other petroleum companies that are operating in Pakistan.
Well, just to add it, that I have access to that data, and that is archived. That data is still there. And then we acquired some very good seismic. It's a high resolution seismic. And Bob, just to tell you that what I did while drilling the well, we get the mud logs with detailed lithologies. So I put the whole mud log on the floor, and I just wanted to see if there are stacks, and in the subsurface I can find the stacks. But even then I couldn't see any stack where Murray is repeated again and again in the subsurface.
Yeah, my sympathies are with you, because I've looked at similar situations, and I've looked at the electric logs of many wells, and that if there aren't clear marker beds, Jed, I mean, one of the challenges would be if you have a big stack of fluvial sediments, and the Murrays are fluvial, it is conceivable that you might not find enough distinctive log patterns or signatures to recognize duplicates, and that's just a possibility. But we would have to discuss the individual case in more detail.
Thank you, Bob.
Yeah.
There is a question in the chat box.
Yeah, I'm just struggling a bit with my own writing up of the geology for our Siwalik book, mainly on the fossils, with the redating of a lot of these, because they're old references. The thicknesses are still good, but the paleomag crons have changed, and it would be really helpful if there, and this is a big job, I know, but if there could be maybe a reference at least for to translate the older dates into the newer ones on the GPTS.
Yeah, no, of course, Kay, you're right. But, a lot of people use Candy and Kent 92 or 95. And it'd be interesting to, in fact, I've asked Dennis Kent the exact question. I've said, well, what is the most authoritative current compilation? And I don't actually know if there's an answer to that. I mean, somebody has to be maintaining those, what's the Gauss-Maniyama date and what that is. And And I don't know, I think that to me, as long as you've stated your source, okay, if you say, okay, I'm going to use Candy and Kent, and we worried about it. I've worried about it, and I've replotted some of those accumulation curves and things, and with newer dates than what I had when I was doing my thesis work, and it doesn't change things very much. They're little changes. There are changes, to be fair. So my suggestion to the community is that it might be we ask Dennis Kent to tell us what his advice would be for the last, let's say the last 15 million years. Just give us a chart for the last 15 million years, or find some irreproachable source that we can all cite. Right now, I cite Candy and Kent.
Well, it's Gradstein, and the publication that's most recent is, I think, 2016. But we've been using 2012 because for our paleontology, it's really important. We're getting down to 100,000 level year resolution. So some of those changes do make a difference for what we're trying to do.
Right. Well, and so which reference are you using, Kay?
It's Gradstein.
Yeah.
2012. I think.
2004, I guess.
Well, this one is
The updated one.
this is the one I bought.
Oh, it's,
and this is
2016. Oh, that's a newer version, yeah.
Yeah, it's the newer one, but we're using 2012 because we already had recalibrated a lot of things, and it is actually hard to find online a definitive source, but you can do it. You have to pay for it. But yeah, our Lisa Tokes, obviously be a source, and Dennis.
Well, it certainly would be helpful if there was if we could define an authoritative version, or at least I guess you're in contact with Lisa. If Lisa is advising you to use the Gradstein 2016, that's probably as good as we'll get.
Well, 2012, but yeah. I noticed in her latest paper.
Okay.
Gary, I just want to add that after Amoco left Pakistan, in Kohat area, there were no oil and gas discoveries. But after 1998, Kohat area is producing 50% of oil production of Pakistan from Kohat.
Yeah.
I think, Kay, in the sense of documenting these old articles that go back well into the 70s, using whatever graphical material was presented at that time, I think what Bob's intent was to just put this as an archive acceptable to everybody. And obviously, probably somewhere we should have an explanation that, here is the current valuation of some of these crown boundaries, like 2.58 for Gauss-Machiyama, as opposed to, I think, what was that at that time, it was less than 2.5, somewhere in there, in the early 70s. So I think that's an important thing to probably do, but I'm not sure that it's appropriate to redraw to every measured section.
Oh, no, I didn't mean that at all. I just meant,
yeah,
no way. But if I found this sort of a Rosetta Stone diagram, and it shows that there are differences in the earlier part of the section and not very much in the later part of the section. But just something like this could be a page in your
exactly.
And then just to alert people not to take those old dates for granted.
Right.
That's Alan Cox had that same diagram on I can reach the
Yeah.
book here, but many of you will remember that the marine magnetic anomaly signature evolved through time. And there's a wonderful Alan Cox diagram showing that same progression of higher resolution through time.
Well, and we have the other added complication that most of these rocks we're looking at are in terrestrial environment where there are all sorts of unconformities. I mean, there are thousands of them in every section, and it's a question of whether they represent annual or millennial or, you know, much bigger gaps of time. And we never, you know, generally speaking, we can't figure that out. Paleosols may give you some indications and such, but you know, I think the discovered stratigraphy, not only are there finite separations between samples, but there's also the unknown position of reversals between samples, et cetera, as well as what's missing. Even if we had, you know, we can't assume that they're perfect records.
Yeah, and I think in a few cases, it's been demonstrated that as we go back to an earlier section and sort of fill in the blanks, we discover a new event. And that induces sort of a rethink of, you know, actually, what is this correlation? Is we've got to really adjust a couple of things here. So yeah, it's, you know, I think a lot of these originally started out as every 10-meter sampling. You know, these vast sections. I mean, you know, get 2 kilometers of section. How are you going to face that? So with like some of the work even over in India, that was Pillam's work, you know, with the Chandigarh crowd, filled in some of the blanks up there in the Punjab reentrant and sort of readjusted the times a little bit.
Yeah, but in general, I mean, Bob, this is a tremendous gift to everyone to have this so beautifully accessible, and it's just now how to build this into something even more useful and broader, perhaps incorporating more of the paleontology as well.
Yeah, well, I would encourage you to look at, I built one for Colorado, again, working with April and Teresa, called coloradostratigraphy.org. And in Colorado, you know, we've got lots of data. And so we've got a series of paleogeographic maps. We've got paleogeologic maps that show the name of the formations. We've got landscape paintings done by Jan Vriesen. We've got a variety of cross sections and measured sections in the Colorado one. So the Colorado website I've used sort of as a test bed at the Denver Museum of Nature and Science. We've worked with lots of colleagues. It was built primarily from the stratigraphic chart. So if you look at the Colorado Stratigraphy website, the main element there is a stratigraphic chart of Colorado. But then we've got a detailed one of the Mesozoic and another detailed one of the Cenozoic. And then we've gone into all these ancillary materials, again, with the idea that I could reach them within my office at the Denver Museum. But if you didn't know that the Rocky Mountain Association of Geologists had published a bunch of measured sections back in 1977, you'd never, I mean, there wasn't any way of really knowing that. So Teresa took a lot of time redrafting some of those, and they're now readily available. And we've also had friends and colleagues that have made cross sections of various kinds, and we're putting those on for Colorado. So it's the Colorado website is sort of a test bed. And there's also one for Lake Turkana, which is called Turkana Stratigraphy. And you'll see a lot of geologic maps on the Turkana one, but some strat columns as well, and some regional stratigraphic cross sections actually. So yeah. From my point of view, I said it before, I'm a librarian. I'm literally assembling information and putting it onto a platform that I'm hoping people can readily access. And particularly in the case of the Pakistan material, where you can download the images or you can download the PDFs. I mean, I think that makes the tools, or it makes the resources more accessible to people who might want to be doing some research in a place where the libraries are hard to get a hold of, and even I mean, even for me, I mean, I'll tell you, and Kay just mentioned it was hard to get the Gradstein book. You know, it's hard for us to get these papers. And I tease Doug because I keep wanting to get a higher resolution of some of his PDFs. And Gary's been helping me get with some of his thesis maps from back when he was doing his thesis. And we can bring these all together and then make them available. And you know, we're stepping on a few copyright people's, you know, here and there, but the intent of Nature or Science or anybody of those organizations is for their published material to get used. And this material was done under the aegis of the NSF, and the NSF will tell you today that they want to have their material in open source environments. And so I think we're honoring the spirit of the time as we break the copyrights. And let them come and get me. I mean, I'm here. They know where. But what you know, this is one thing that we said last night is it'd be fun to have some kind of a listserv of people that were interested in talking about the Siwaliks or furthering some of these discussions. We've used up an hour here, so I'm sensitive to people's time. But if again, I'm looking for where to go in the next few years, you know, let's say the next 2 to 3 year time frame with both the website and with the chance to chat with people across the world. And one of the silver linings of COVID is that it's given us this, you know, we've realized these tools can be used. And, you know, I never Zoomed. I didn't know the word Zoom until, you know, March or April. And here I am. I'm a permanent Zoomer. I mean, it's a
so are we all.
So are we all. And we can Zoom easily. So, you know, we can Zoom across the world. And if there's students in Peshawar or in Islamabad, or if there's people in the GSP in Quetta or in Lahore or Islamabad that wanted to follow up on any of this, you know, we're here to be as helpful as possible. And the website just gives us sort of a structure. So as people contribute information to me or offer higher resolution maps, we'll put them up. And Kay, I'll just mention that the map at core is you know, it's a little bit sketchy because it was made from air photos in the day, and we all know how it was made, but it wouldn't be too awfully difficult to redraft it. And what I do is I use Google Earth, and I take Google Earth images and I put them as underlays in Adobe Illustrator. All my maps are made in Illustrator, but then they match Google Earth. So you can take the map and you can, Google Earth has an overlay thing. You can put them in as an overlay. So you can be looking at Google Earth with all the facilities of Google Earth with the maps on as an overlay. And
how are you advertising this amazing synthesis that you've done in terms of all of the geology departments in Pakistan and India and China and other places that would be interested in these, you know, accessibility and don't have the wherewithal to, you know, try to attempt this sort of synthesis?
Well, Doug, I mean, that's the question. When I was in Pakistan giving talks a couple of years ago, this website didn't exist, but the Colorado one did exist. So that was the kernel of the idea was generated 2 years ago when I was giving talks in Pakistan about the Siwaliks and climate change. And then over the last couple of years, April and Teresa and I built the website, you know, drawing on materials that you provided and Gary provided and others, as well as what we could scrounge around. And this is the advertisement. And last night was the advertisement. We had 50 people last night, mostly from Pakistan. And, you know, it was 2 screens. We couldn't see each other. It was, you know, sort of a hassle, but they all heard about the website. And so I think that, you know, I'm eager to hear your suggestions and advice, Doug, but this is the kind of thing that has to move by word of mouth. I tell you, even in Colorado, I have a dickens of a time getting people to really know that the Colorado site is there. And I go to schools and give talks. And when I give the talks, I do just what I did here. I go to you know, School of Mines and I bring up the website on the screen and we talk about the website live. And when you're in the field, it's super cool because you tell everybody to pull out their cell phone and it's on your cell phone. As you're sitting there fussing about the Morrison formation, well, don't fuss about it. Just pull it up on this thing and at least you'll see the consensus of what the Morrison is. So you could say, well, you want to move the boundary up or down a little bit, but you can at least see what the consensus is. And it shows up fast. I can't believe it. I mean, while my breath is still going, I'm going to show it to you. It's an unbelievable thing. There's a little special app that was built by April here somewhere. You push the thing somewhere on here, right there. And while you're breathing, suddenly there's Colorado stratigraphy. And it's you know, in my personal opinion, it's a killer app.
Well, you need to get on Twitter about it.
Well, they tell me I need to be on TikTok.
That would help.
So,
well, let me throw in an idea. This is Catherine Badgley from Michigan. I think it might be interesting at some point to use your website as a basis for a kind of a collaborative course that could be just a brief and like a short course that could just be it could be even a 8 or 9 hour introduction to the Siwalik geology. And then some of us, if interested, could also contribute, you know, some information about the paleontology. And it could be designed in such a way that it could be available to people in any country, but I think particularly oriented to students in Pakistan, so that they could understand, you know, kind of the synthesis of all the different projects that have been done, but both by Pakistani geologists, but also by the people who visited there over several decades. And I've long thought that would be, I wish that was something we'd been able to develop when we were still able to go on a regular basis, and to develop a connection with one of the local universities to let people know what an amazing record they've got.
right. Well, Catherine, I mean, you've got your idea is spot on, and it's this idea of you create these courses like a master class, and you know, I could pick 5 or 6 people that I can see on this screen here and say, okay, you're going to talk on you know, January 28th, you're going to talk on February 4th, you're going to talk on March 1st, you're going to talk on, you know, April 7th, and you know, for any individual one of us to give an hour talk on some piece of the Siwaliks, you know, how hard would that be? And so if you took the collective wisdom here, and if we tapped into, you know, the extended family of the Yale Harvard group and the Dartmouth Peshawar group and the DSP and the Center for Excellence and the PACS,
Right.
you know, it's just all you need is somebody to coordinate it.
Right. And actually you could record the talks and they could be available on the website as well. And
Yeah.
then people could watch them whenever they wanted. So, and they could be updated, you know, there could be a few more added each year as you got more people to give talks, for example, about the stable isotopes of the soils as well as of the fossils.
Yeah. Well, I sense you volunteering to
Actually, we're in the throes of writing a collaborative book about the Siwaliks, and I'm not going to stray from that task. But when that's done, and probably, you know, about a year from now, we'll have a grand synthesis of all the work of the Yale Harvard teams with interacting with our colleagues in Pakistan. And I think what we'll be thinking about ways that we can get the information out in sort of related formats. And, you know, with this beautiful website that you've created, this would be a good sort of organizing platform for us to add more.
Well, I'll give you a vignette. We were organizing a symposium on water and energy in Colorado, through the Colorado Scientific Society, and I'd organized 15 or 20 speakers, and it was going to be held at the Denver Museum, and we were fussing about who was going to pay for lunch and how many coffee breaks and all this stuff. And then COVID came along, and we collapsed, and we said we had to stop. And then after a while, I was so frustrated that we had built all the momentum, and we flipped it over into a webinar, and we had our 16 or so speakers over 4 different periods, and stretched over a couple of weeks. I think it was twice a night. Hang on, Javed is calling me. Let me just, because we all know Javed, I'm just gonna say, hey, Javed. Yeah. It's on right now. If you go to the website, or to the Zoom link.
Sir, link.
Yeah. Come on in and say hi to people.
It's a different link. I'm sure I copied him. I don't know. I sent him an email. Yeah, you did. Okay.
Yeah. So anyway, I think we'll see Javed in a second. But long story short, Matthew, the webinar required less time for the individuals because they came on for their hour talk or whatever it was. They didn't need to drive to the Denver Museum. They didn't need to have lunch. They didn't need to go to the coffee break. And I mean, I don't want to say that it was easy, but it was not difficult. You assembled the people. The Denver Museum has a magnificent Zoom master, and the Zoom master pulled everything together and hosted everything, and it was easy peasy. So if later, let's say in the springtime, and I'm choosing sometime that's not immediate, but it's also before the end of your book. But if in the springtime, if we wanted to borrow an hour of your time to talk about your favorite topic about the Siwaliks, I mean, I don't think that'd be that difficult. And I think that many of us could do that. And it would be, I think it's a wonderful idea, and a, sort of a master class in the Siwaliks, it'd be great.
Sure, I agree.
So does anybody else have, I mean, again, I'm respecting people's time. Javed Khan is trying to join. He's in New Jersey, I believe. And so he might be able to say hi to everybody, but I appreciate it's getting late on the East Coast. So I see Kay.
Right. Yep. I should go too. I'm still grading papers for my class, and I need to get back to that as well. But wonderful to see everybody. And Bob, thank you for this wonderful accomplishment.
Well, and we might lean on everybody for some help. So, so I think now that you know what the structure is like, we can be a little bit more proactive about it.
Great. Wonderful. Good.
Okay. So thank you all, everybody.
Bob, it was wonderful. Thank you so much. Thank you very much. It was excellent.
Yeah. No. Good to see you all.
Good to see you too.
Take care.
Thanks.
Hey, Doug.
Hey, Doug, how was retirement?
Very quiet every day, just resting on the couch. On the whole, it's been great. We had opportunity to do lots of travel, and still doing work with the National Academy and such, and got grandkids at the few thousand miles away, but we see them from time to time.
It's getting hard. At least the last 6 months, we've not done much of that at all.
Well, very fortunately, a year and a half ago, we replaced our VW camper with a newer compact camper where we can be pretty independent. So we've gone up to Seattle and out to Montana and Colorado and various things on a number of trips this last year, and felt that we could be pretty well isolated from other people, but still see lots of terrain and drop in on relatives who have also been pretty conscientious about not interacting with the general public. I have a daughter whose husband bought 6 months worth of groceries back in March, which I think they're more or less finished up now.
So I'd like to interject. It's Mahmoud from Islamabad. Great to see all of you.
Good seeing you.
I have to rush for a meeting. I'm working at National University of Medical Sciences. So I'm sorry, it's going to be 9:20 here in Islamabad. Great to see all of you, and all hats off to Bob.
Yes.
We'll get in touch soon.
Yeah, thank you
Take
for
care.
coming. Thank you.
Take care.
Yeah, Bob, Doug, I have three cousins in Santa Monica.
Uh-huh.
Two in Ontario and Victorville.
Oh, wow.
So it's, this both sides of the family, and, we just haven't seen them for a long time. And I guess things are all pretty tough in LA right now.
Yes. The Santa Barbara County is out of 52 counties, we're the 6th from the bottom in terms of the lowest rates of COVID cases here. But LA is not a place we want to go.
No.
We were supposed to fly to Ontario, Canada for Christmas, and we've decided to nix that plan and stay quietly here.
Well, Dartmouth has been really on the top of things in terms of COVID testing. Since July 1, they've done about 68,000 tests. Now,
Wow.
a lot of that's redundant because, faculty coming in and out, students coming in and out 1 or 2 times a week. 13 cases, 13 positives
Wow.
of 68,000. It's a 0.02.
Yeah.
It's truly amazing. And Stanford, I think, and Colby College are the 3 lowest in the country for universities.
Wow. Well, that's great. I hope they're able to sustain that after everybody goes home for Thanksgiving and for Christmas and comes back.
We'll see. Come July or January 17th, I think, is when they're coming back.
Yeah.
Javed, how are you?
Yeah, very fine. How are you? Seeing you after a long time.
Yeah, it's been a while.
Yeah, I sent you a message today. Did you receive that?
Today?
Yeah.
I don't think so. I could
But
look.